In this video, I want to talk about custom getters and setters in JavaScript. These allow us to customize what happens when someone sets an object property or reads its value. They're super cool, they're a fun new feature of the language, so I do want to take some time to talk about them. To explore them, we're going to start with a brand new file in the OOP directory. Then we'll integrate what we learn into the person class, and you'll be integrating what we learn into the hangman class. But we're going to kick things off right over here. I'm going to call this file something like get-set.js, and we're going to start by creating a basic object. So let's create a const. I'll call this one data. We can call it whatever we like. And we're going to set up an object. And on there, we're going to say that we're just going to store a location. Maybe it's a location of a store, the location of a person, or anything else. Now, this property is going to change over time, and we're also going to read its value to figure out the current location. So let's go ahead and mess around with that. Down below, code that uses the data object. So we have our data object defined, and now we're going to write some code that actually manipulates it. Let's say that we set data.location equal to something. I'm going to set it equal to the string Philadelphia, my current location, perfect. Then we're going to log it. So console.log data location. There is absolutely nothing earth-shattering about the code we just wrote, but let's go ahead and run it just to make sure it works. Over in the terminal, I'll be cding into OOP and using node get-set.js to run the file. Now over here we are seeing Philadelphia, meaning our program is working as expected. Now what we're doing here is we're using just a regular object property. So whatever value we set on location is the value that actually gets stored. Then we read that value verbatim when we read that property value. With custom getters and setters, we can define logic to override that. So we can do something behind the scenes to set a value or get a value. This could be pretty useful. Imagine, for example, that there is a little bit of spacing before and after our string. Maybe we want to perform a little data sanitization before we actually store the location. Maybe I want to use the string trim method, for example, just to make sure that there are no extra spaces. Maybe there's a situation where I want to convert all of the characters to lowercase. There's a lot of potential things we might want to do to sanitize and validate our data. Right now, we can still get that sanitization and validation set up. There are two main ways. Down here in the code that uses the object, I could write some code to make sure the data does indeed match what I expect. I could write code that uses trim. I could also create a function on this object like setLocation, and that function could take the value, it could use trim to clear up the spaces, then it could correctly set location. All of that works, but it actually relies on the person using the object to do something special. They either have to manually use trim or they have to call the function. They can't stick with a simple setup of just setting and reading property values. With getters and setters, we can though, so let's go ahead and take a look at exactly how this works. Inside of our object definition, we're actually going to remove the location property as it currently stands, and what we're going to do instead is set up what looks very similar to a method. The method name is going to be the name of the property that we're trying to work with. In this case, it's location. So we set up location, we set up our arguments list, and we set up our method function body. Now, currently, this is just a standard old method, something we've used plenty of times before. To make it a custom getter or setter, allowing us to intercept when we set property values or get property values, we have to use either set or get right before the function name. So let's go ahead and start with a getter. Right here, get space location. This is going to allow us to override what happens when someone tries to fetch a value. And that's the exact stuff we do down below, where we try to fetch location off of data. Now, what goes inside of here? Well, what goes inside of here is us returning the value that we actually want to send back. So the value that the user should get when they try to read the property. We can go ahead and prove this by returning something like a string. I'm going to return the string. This is a test. Now we can save get set. I can rerun it from the terminal. And what are we getting? Right here, I'm getting this is a test for the property printing. So by setting up a custom getter, we can override what happens when someone reads a value. Now let's go ahead and set up a custom setter as well. We're going to provide this in the object too. So right here, I'll put a comma. And on the next line, we're just going to use set before location. Now, the setter does get called with an argument. It gets called with the value that the user tried to set. So here it would be whatever on the right-hand side of the assignment operator for location. So we get that value in, and we can just name that argument value. It is the first and only one. Now it's up to us in the setter to actually do something with the value. Maybe we want to go ahead and trim it. Maybe I want to validate that it's of a specific type. There's all sorts of things we might want to do inside of a setter. For us, let's just go ahead and trim it, making sure we remove any spaces. So right here, what are we going to do? We are going to use trim. So I could just say value equals value.trim. Now at this point, we're not actually storing it anywhere. We are going to store it. We actually can't store it on location because that's taken by the getters and setters. Let's go ahead and prove that. So I'm going to, down below, not read location. I'm just going to dump data to the console. Then over here, we can rerun the program, and what do I get? I get an object where the location property is already set. It's set equal to our custom getter and setter functions from up above. So if we want to store this data, which we do, we just have to pick a different name. So right here, I'm going to use the property name prefixed by an underscore. So this dot underscore location. That's where the data will actually live. I'm going to set this dot underscore location equal to value. Now I can just use value.trim right here instead, allowing me to remove the line from up above. Perfect. So we're setting this secret property when someone actually sets data.location. Let's go ahead and test that out. I'm going to save the file. I'm going to rerun things from the terminal. Right here, location is still pointed to our getters and setters, and underscore location is now the string Philadelphia. Notice that all of the leading and trailing spaces were removed by the trim method itself. So now we are close to a working solution. The only thing we really need to do is allow the user to actually read the location. So right now, data.location still returns the string from up above. We can fix this by returning instead this dot underscore location. There's no need to perform any manipulation inside of the getter. We are just performing that in the setter, allowing us to do something with the data. In this case, trim it. Now our example should work as expected. Over here, I can rerun the file, and I get Philadelphia printing with no leading or trailing spaces. So using getters and setters like this allows us to customize the behavior of an object. Someone who's using the object doesn't need to worry too much about what exactly is going on behind the scenes. If they try to set a value like this one, behind the scenes, we go ahead and manipulate it. When they try to read the value, we show them the new value. So this is great behavior because it allows us to perform things like validation, sanitization, or anything else we might want to do. Let's go ahead and take a look at how we can add one more thing to this example to make it a bit more interesting. Let's say that as our program runs, the location value changes. So later on, data.location equals something else. Let's say it equals New York, for example. Now we print the location and we get New York back with that leading space removed. That's great. But what if we wanted to figure out all the places we've been before? Currently, there's no way to do that because we're not storing that information. We override data.location, losing the fact that we were ever inside of Philadelphia. If I print data, nowhere on there are we still going to see Philadelphia. But with a custom setter, we don't just have to set a single property. We could do anything else we might want to do. For example, on the data object, I could create a locations array. I'll start it off as an empty array and we'll add locations in as they end up being set. In our custom setter, we can now set this dot underscore location, and I can also push it onto locations. So this dot locations, we're going to use dot push to add an item. I'm going to add this dot underscore location, which is the new location that just got set. Now we have a very simple way with just 2 lines of code to track all of the locations that have ever been set. We can prove this by removing the location property and just printing data to the console. I'm going to save the file. I'm going to rerun the program, and what do we get? We still have our regular underscore location property, which is still correctly set to the most recent current location. We still have our getters and setters, and now we have our locations array with 2 items, Philadelphia being the first and New York being the second. So these getters and setters are super useful for situations like this. It really allows us to customize the behavior of an object, allowing it to fit our needs. Now what I want to do is use this exact same behavior, custom getters and setters, with our classes, the Hangman class and the Person class. Let's go ahead and work on the Person class together, and the Hangman class will be your challenge for the video. What I want to talk about is this setName method. The setName method allows us to pass in the full name, and then we break it up into its individual pieces and we set first name and last name. This works because we call the method passing in the data. But we can actually create a custom setter to do this for us. So down below, we would be able to do something like the following. I could set me dot full name equal to a completely different name. I could use Clancy Turner, for example, and this would behind the scenes correctly set first name and last name, allowing me to still use that information in other places, like get bio. So let's go ahead and actually see this work. We're going to create a custom setter for full name up above, right here. All I'm going to do is add set in front of set name. Then I'm going to replace set name with the property that we're trying to add the custom setter for. That is full name. And we're still going to take the full name in as the argument. We're still going to split it up, and we're still going to set first name and last name. So the method body doesn't actually need to change at all. All we have to do is add the setter in. Let's go ahead and actually test things out. Down below, we're creating a new student, and we're using getBio twice. GetBio does read this first name, so we'll be able to figure out if this is actually working as expected. I'm going to save person.js. Over inside of the code, I'm going to run node person.js. And what am I getting? I am getting Clancy is passing, then Clancy is failing. So we were able to correctly set both the last name and first name by setting full name. Now, we've also proved that you don't need to have both a getter and a setter for each property. That is not required, though it is common. For example, down below, for employees, we do use their first name and their last name back to back. What if we wanted to switch this up using a custom getter instead? We're going to do just that. First up, let's create an instance of employee down below. I'm just going to switch student over to employee. And I'm going to switch the grade for the student over to the employee's job title. And there we have it. Everything else should still work as expected. We already use getBio twice, allowing us to make sure that things are going to work. So right here, what are we going to do? We're going to remove both of those where we get first name and last name individually. And all I'm going to do is get this full name. Now, currently, this is not going to work because there is no custom getter for full name. Up above, though, we're going to be able to do just that. Get full name. This one doesn't take any arguments because it's the getter, not the setter. Whatever we return is going to be the value used. So I'm going to return a template string where we go ahead and get the first name. Then we add a space and we go ahead and get the last name, just like this. Excellent. Now our code is going to work as expected, even though we're using full name, which doesn't actually exist. What we have here is a computed property. We compute the full name based off of the first name and the last name. I'm going to save person.js. Over in the terminal, I'll clear the terminal output using clear just to keep things easier to follow. Then I'm going to rerun the person.js file, and I am getting an error. Update grade is not a function. Whoops, I switched the person from a student to an employee, but I'm still using update grade, which doesn't exist. I'll remove that as well as the second getBio call, save the file, rerun things, and this time around, we're getting the expected results. Clancy Turner is a teacher is coming from this method right here, getBio for the employee, and it is indeed using full name correctly. So this is just another example of where custom setters and getters are going to come in handy. We don't need to store full name since we're already storing all of the pieces that make up full name. Now let's move into challenge territory. You're going to be making some changes to the Hangman class, so we'll be making some changes to the class itself and to how we use the class over in app.js. I'm going to kick things off by adding the challenge comments right up top in this file. So right here, this is what I want you to do. The big picture goal is to convert both getStatusMessage and getPuzzle over to custom getters. So step 1, convert getStatusMessage to a custom getter for statusMessage, and then convert getPuzzle to a custom getter for puzzle and change the usage in app.js. So in app.js, in the end of the day, what I want to be able to do is access.puzzle right here to get the new puzzle, and down below, I want to be able to access statusMessage in order to get the status message. Now, clearly, there's still a bit of code we need to run in order to get that done. That's why we're using custom getters. So take some time to knock that out and then actually test your work. Make sure the game still works for all of the cases we've talked about. Pause the video, and when you're done, click play. How'd you do? Let's go ahead and kick things off by finishing up the conversion in app.js, which is actually step 3. I already read puzzle and status message up above for the initial values. When someone presses a key though, I want to update the screen. So right here, I'm going to read puzzle, and down below, instead of calling getStatusMessage, I'm going to read the status message property. Now we can actually save this file in its current state, though in the browser we're going to see absolutely nothing since all of these properties are going to return undefined. They're never set up and there's no custom getter. That means nothing comes back. We're going to create a custom getter for each though. Let's go ahead and move into that. I'm going to start with getStatusMessage. And remember, the name for the method needs to match up with the property. So here, statusMessage aligns with what we're reading over here. Now to make it a getter, all we do is we put get up front. If I wanted a setter, we would put set up front. The rest is actually already good to go. All we do is we return the string, so this is actually done. And we can do the exact same thing down below for getPuzzle. I'm going to remove the old method name. This time we're creating a getter for puzzle, and there we go. Everything is wrapped up. Super easy challenge, though it might have taken you a little bit to figure out exactly how to make those changes. Now we can remove the comments from up above. We can save the file and we can test things out. Over in the browser, I am seeing the puzzle and the status message, which is great. We can go ahead and make sure that they change dynamically. I will press something like C, which is a guess that up top message updates. I'll press something to update the bottom message like Q. That is indeed a failure. And as I play through the game, we can see that everything works. So that's it for this video. In this one, we learned about custom getters and setters, allowing us to override what happens when someone sets a property value, like data.location equals something, or gets a property value, such as accessing location off of data. We're not going to be using these for everything, but they do come up in situations where we want to run some code whenever a property value gets set, or run some code whenever someone reads a property value. That's where we're going to stop for this video, and that's where we're going to stop for this section. In this section on object-oriented programming, we took a deep dive into how JavaScript gets this done. We looked at prototypal inheritance, and we saw how we can use prototypal inheritance in our own code. We created some of our own classes, and we explored how JavaScript uses this behind the scenes. For example, we saw that an array is really just a customized type of object. Now that we have this information in place, we're going to continue on to the rest of the course. We're going to take a look at how our applications can interact with external data sources. I'm super excited to get to that, so let's go ahead and jump right into the next section.